Okay, so this is the second video. So what temperature is, if you think of a thermometer, you have your bulb in there. As temperature goes up, then the actual kinetic energy of molecules in a gas increases. So for that to happen, as the temperature goes up, then so does the speed of the molecules. We define this better later on, especially in year 13, but this is actually what happens. So temperature is directly related to the kinetic energy of the gas. Particles continually collide with the walls of the container they are in. To change the direction of the particle, force is required. Because of Newton's third law, there must be an equal size force pushing out on the wall. So if you think about this particle here, it's got a velocity v, and it's coming in, it's hitting the wall, and it's going to bounce back out again. Okay, the wall must apply a force into it, but then the ball's going to apply, the particle is going to apply an equal opposite force against the outside wall. So as this object hits the wall, because there's a force, and you could even say that there is an area to this wall. Okay, let's try that a different colour so you can see it. So this is the end wall. Okay, so it has an area. Then because there's a force over an area, it must then create a pressure. So one molecule hitting a wall will create some pressure as it changes direction. Now because this thing's going to be coming in with a velocity and bouncing off here with another velocity out, and you require a force to change it, and it's going to be equal and opposite. If we increase the kinetic energy, then we must also increase the velocity, and then we must also then increase the force to change the direction. Now because you've increased the force to change direction, you must then have also increased the pressure, because force and pressure are proportional. Temperature versus pressure. If you increase the temperature of a gas while keeping the volume constant, the kinetic energy of the molecules will increase, meaning the velocity will increase. Raising the force due to the collisions, and also the time between them. Okay, and thus raising pressure. So you just imagine the molecules hitting the side a lot harder, and also the time between each collision is a lot shorter, so that means the pressure is much higher. Because the pressure is the sum of the force due to the collisions with the walls, the pressure must increase if temperature increases. Essentially what we said before. So here's a little diagram showing it. So this is cooling it down, so there's a gas down the bottom there. The molecule is going to slow down, and so pressure will decrease. If you increase the pressure on a syringe, you'll decrease the volume of the gas at a constant temperature. Okay, so in other words, let's say we had a syringe. You block the end of it with a cork. Okay, and you have a plunger going into it. Now what you can do is, if you start adding masses to the top of this plunger, then it's going to decrease the volume, and if you did it slow enough, the temperature wouldn't change. So that's saying that the force due to the collisions of the molecules bouncing off the walls is not enough to overcome the force on the outside on the volume. However, conversely, if you imagine a balloon, okay, and you heat the balloon up, then the molecules are going faster. They will then expand the balloon to be larger. And that's essentially what Boyle's law talks about. The relation of this one is inverse, okay, so its pressure is proportional to 1 over the volume. And before we saw that pressure is actually proportional to temperature, so as you raise the temperature, then the pressure will rise. And what we can say is that pressure times volume is actually constant. In other words, if you increase the pressure, you decrease the pressure, because when you multiply them, you want to keep it constant. So an example of that could be if you had a pressure of 1 Pascal and a volume of 1 meter cubed, then what's the constant? We're going to do 1 times 1, which equals 1. Okay, there's my constant. Now let's say I want to double my pressure. What will my new volume be? So pressure is going to be 2 multiplied by volume is equal to 1. So 2 times a half will equal 1. So if the pressure on a balloon with volume 0.002 meters cubed was doubled from atmospheric pressure, what will the new volume be? So atmospheric pressure, you could say 10 to the power of 5 multiplied by 0.002, and that will be some sort of constant. Now what you do is you then grab that constant and say that we're now doubling the atmospheric pressure. I'm going to multiply it by some volume to get that constant. So you can solve for that.